Okay, this is Mechanics Applied Math 5.1 to 5.4, and this is the second time I record, not the whole quiz, but I had trouble with my pen features. Haven't used this tablet in a long time. I'm outside of the I'm outside of the country, for that's why I'm using the tablet, so please excuse the mic. Anyways, consider a particle of mass m and velocity Consider a particle of mass m and velocity v accelerating at a rate a. What's this? It did not look like this before. Okay, anyway, let me wrap this up. Basically, they're saying what is true about momentum. What do we know about momentum? P is equal to mv. P is a vector. If you don't know that P is a vector, think about P is equal to mv. Isn't velocity a vector? Yes, right? So when you have a scalar multiplied by a vector, you will end up getting a vector. Okay, so what do we know about momentum? Is momentum ma? No. Is it a scalar quantity? Obviously not. Is it vector? Yes. It's mv? Yes. Its unit is kilogram meters per second? Yes. If you don't know what the unit is, for any physical quantity, mass is kilograms, right? And velocity is what? Meters per second. So the unit of momentum is just kilogram times meter per second. Another thing is, if you're taking IGCSE, if they ask you to define anything, let's say مثلا they say define momentum, and I saw this in a lot of past papers, they would tell you to just define a certain physical quantity. Think, do I have a formula for this quantity? Momentum is P is equal to mv. So if they tell you define momentum and you just wrote this, you would get it correct. That's it. Okay, so I'm saying this because maybe it comes in the physics written part. Define charge, define work, define whatever, anything that has a formula. That's literally, it's definitely, you don't need to say anything else. Okay, question 2. A boy kicks a ball of mass 450 grams directly at a vertical wall with a horizontal speed of 40 meters per second. So we can take u to be 40 meters per second, right? U yani initial velocity, if someone still doesn't know at this stage. The ball rebounds off the wall with a speed of 26, so its final velocity is 26 meters per second. I'm taking u to be initial and v to be final, okay? Take the rebound speed to be in the positive. This is your key over here. The rebound has to be the positive. So what is the change in momentum, and if the mass was doubled, blah, blah, blah. Okay, right, yeah. When working with these rebounding and collisions and whatever, I always prefer drawing a diagram. Okay, so you kick the ball and it rebounds off the wall. So you're kicking it with 26 meters per second and it rebounds at what? 40 meters per second. Type, what do you need to always take in any momentum collision exercise? You should always take what? Always choose your positive direction. If they don't give it to you, they will usually ask you for the magnitude, because the magnitude doesn't matter this time. But you need to pay attention. If they tell you take the rebound speed to be positive, that means if you solve the other way, you're gonna get the wrong answer. Okay, so let's take the rebound speed to be positive. So that means the left is positive and the right is negative. طيب. We have our diagram, we have everything given, we have our mass, we have our velocities. What are they asking for? The change in the momentum. What does the change in momentum mean? That means delta P. In other words, what does that mean? Momentum final minus momentum initial, right? What does that mean? That means mv minus mu, right? Because we know P is equal to mv. The final momentum will be mass times final velocity. The initial momentum will be mass times the initial velocity u, right? So let's substitute our values. 0.45 times the final velocity was 26 minus the mass again 0.45 times the initial velocity is how much? Negative 40. The signs matter. Wallah, they matter. You can't solve. Oh, is it? This is the other way around. This should be 26 over here, and this should be 40. Sorry. Anyway, the signs matter, and they are pretty much what change the whole dynamic of the question. So when working with collisions and momentum, please choose your negative and positive and solve accordingly. You can't solve without it, okay? Anyway, over here you should get Can I not press on my calculator? Okay, yeah. So when you do this, you get 29.7 as you can see. Okay, so 29.7, and the unit is you could say kilogram meter per second, or they say Newton second. Why is it Newton second? Because another formula for it is F times delta T, which is force is Newton and delta T is seconds, right? So I'll talk about the formulas in a second. But anyway, that's part A. Part B, if the mass was doubled while maintaining the same incident and rebound speed. So the mass was doubled. Okay, what will the impulse be exerted by the wall? Type the impulse exerted by the wall. If you don't know what impulse is J. J is equal to F delta T. Okay, you should know that impulse is basically just another fancy way of saying change in momentum. Okay, you need to know that. Okay, it's literally just a fancy way of saying it. Okay, ma fiya shi. So if you see change in momentum or impulse, they're the exact same thing. Okay, and they literally have the same formula. J is equal to delta P is equal to M delta V. So sometimes if you have, they ask you for impulse and you only have the mass and velocity, you can just use M delta V. Okay, as we did here, this is M delta V. Because if you factor out M, take M out, you're going to get V minus U. And what is V minus U? Isn't that just delta V? Yes. Okay. Anyways, so they're asking what is the impulse. In case someone gets confused, hey, what's impulse? It's the same as change in momentum. So they're saying what happened, what the mass doubled. So let's go back to our formula. They're saying the velocities were kept constant. If the mass was doubled, what does that mean? Yani? What does that mean? It means I'm multiplying by what? By 2. Right? Let me write. Our change in momentum is equal to M V minus U, we said, is what? 26 minus 40. Right? Type هنا they're saying شو the mass was doubled. يعني هون what did I do? I multiplied it by 2. Type إذا هون I multiplied it by 2, what do I have to do on the left command? I have to multiply by 2. So what's going to happen to the impulse? It's going to be multiplied by 2. So this 29.7, you take it on your calculator and you multiply it by 2. 59.4. Okay? If you don't believe me, just go to the mass, change it from 450 grams, make it times 2 and make it 900 grams, and solve again and get a new answer. But this is just the quick and fast way. Okay? Question 3. A particle of mass 4 kilograms is initially at rest. A horizontal force of magnitude 10 newtons acts on the particle for 8 seconds. What is the final speed of the particle? طيب okay. عندك particle of mass 4. M is equal to 4 kilograms. They're saying that a force F 10 newtons acts for 8 seconds. طيب what is the final speed of the particle? Hello. So this when you have a force for a certain amount of time, you can think of F delta T, right? Which is in this case 10 times 8, which is 80 Newton second. طيب you can tell me وليد هيدا شو بيفيدني؟ طب أنا what do I know? What do we know about the relationship between this impulse and the change of momentum? Are they equal? Yes. Okay, so when you see an exercise like this, and you will see, I'm sure you will see a question exactly like this in the exam, and they ask you to find the final speed, just remember M delta V is equal to the J, which is equal to F delta T. Okay, so the change of momentum is equal to M delta V, and this change of momentum is also equal to J, which is equal to F delta T. So in this case, 4 times delta V is equal to 10 times 8. So you're going to get 4 delta V is equal to 80. And since we're starting at rest, that means U is equal to 0. So basically 4V is equal to 80, and V is equal to how much? 20 meters per second. Very, very easy. Okay? So if you see something like this with a force for a certain amount of time and you want a velocity, always remember, impulse is equal to change in momentum. يعني F delta T is equal to what? M delta V. Very simple. Very nice. Very easy. Okay, a particle of mass 1.5 kilograms is moving with a speed 7 meters per second. We have a speed U, and we have its mass M 1.5 kilograms, right? Type, it's in the positive direction. Hello. Its speed changes to, whoa, that was a voice crack. Its speed changes to 3 meters per second, and its direction is now reversed. طيب. what is the initial momentum, what's the final momentum, and what is the impulse? طيب, let's take a look. I will see to find the initial momentum. I think it's very easy. P is equal to mv, so 1.5 times 7, which is 10.5. Okay, you can do it on your calculator. Kilogram meters per second. Please don't forget the unit if it's in the written part. Very easy. Type the final momentum of the particle. Its speed is now 3 meters per second and the direction is reversed. So v is equal to negative 3 meters per second. Right? Why is it negative? Because we changed the direction of motion. So yalla. Again, calculate the momentum again. 1.5 times the velocity negative 3 قد حتكون minus 4.5 joules. Very easy. شو joules قصدي kilogram meter per second. طيب, what is the impulse? Now someone's gonna tell me, Walid, impulse J is equal to F delta T. ايش دخل الفورس وشو دخل التايم? Where did you get force? Where did you get time? Man, I'm telling you again and again and again. Impulse is just a fancy way for saying change in momentum. Okay? طيب, let's see, change in momentum. Didn't we calculate the final momentum? And didn't we calculate the initial momentum? Can't you just do final minus initial? Can't you just do that since we have the values? Of course we can. So it's going to be minus 4.5 minus the initial one, 10.5, which is minus 15 kilogram per meter per second. Or you could say minus 15 Newton second. Okay? Very easy. If, let's say, they cancelled part A and part B, how do you calculate impulse? Remember, impulse is just a fancy way for saying delta P, change in momentum. If you have force and time, perfect. خلاص. You don't have to do anything further. But here you don't have force, you don't have time. So you have to think شوي. What did Walid say? Impulse was a fancy way of saying change in momentum, which is just what? Mass times delta V. Okay, so 1.5 times the change in velocity. The final velocity is negative 3. The initial velocity is what? Minus 7. As they 7. So it's going to become minus 15 Newton second. I'm going to turn on my cursor. I think it's better if you see my mouse. Anyways, I think these exercises are very easy. Until now, nothing hard. I fear I took 12 minutes for 4 easy questions. I'm going to pick up the pace right. A billiard ball of mass 0.17 kilo is moving with speed of 10 meters per second due west. So we have again the mass. Okay, and we have its direction is due west. Let's draw a diagram. Okay, no, let me finish reading the question, then we draw a diagram. So a cue stick strikes the ball such that it now starts traveling at 5 meters per second due north. What is the magnitude of the impulse delivered to the ball by the cue stick? Type, let's take a look. So we're going هيك 10 meter per second. Okay, hello. Then we get hit. We're gonna go now what? 5 meter per second. Type. What do I feel like someone is gonna do is, and this is completely fine. Really, this is completely fine. Okay, is he's gonna do the magnitude of the impulse. He's gonna say, oh, we don't have force, we don't have time, right? What did Walid say? For impulse, it's F delta T. But if there's no force, no time, you remember what Walid said. It's just another fancy way of saying what? It's another fancy way of saying change in momentum. We have our initial velocity and we have our final velocity, so we can find the change in momentum very easily, right? For our change in momentum, the impulse, which is just the same way of saying change in momentum, is going to be equal to m delta v, right? For 0.17 delta v. What is our final velocity? 5, right? Our initial velocity is 10. Why do I feel this is so wrong? Hold up. Yeah, I had to check this twice just to make sure that what I'm saying is correct. And like I was saying, someone's going to do this change in momentum, which is mass times delta v, right? M delta v. The final is 5, the initial is 10. كله تمام. He's going to get 0.85. He's going to put it, he's going to check his mark after the exam. He's going to see, I got it wrong in applying the impulse momentum principle in Newton's second law. Why is this wrong? Now, honestly, I want you to pause the video and think, why can this properly be wrong? Okay, the mass obviously there's nothing wrong with it, but something is wrong with the velocities. If you want, pause and think about it. But why this is wrong is because, Habibi, how can you subtract 5 meters per second due north or 10 meters per second due west? They're not in the same direction, you can't. Mamnu. I always tell the people who watch my videos, from when I used to record the CAs, whenever you're working with different dimensions, can feel one dimension is either positive or negative, right or left, صح? But when you're working with two dimensions, up or down or right left, you need to use vectors. Okay, please use vectors. ماشي. طيب, if I'm using vectors, I can't model the velocity as simply 10 meters per second. Okay, I need to model it as a vector. It's 10 meters per second due west. What does it mean? It means it's going to the left like this. طب as a vector, what is this? Isn't this minus 10 I plus 0j? Right? Because it's 0j because it's just going to the west. If they said مثلا if they said مثلا 10 meters per second at 20 degrees, how would you do it? You'd say 10 cosine 20 I plus 10 sine 20 j. Remember this? You remember how to get the I and j vectors? This is the horizontal component, this is the vertical component. You have vectors also, I think it's required for the final. I'm not sure actually. Anyways, when you have two different directions, two dimensional, you need to model it as a vector. If it's west, it's going to the left. If you don't know, these are the coordinates: north, south, east, west. West is to the left. The minus 10 I. Type. Plus how much j? 0j, because it's going strictly west. Tab here 5 due north. What does that mean? 0I plus 5j. Because what does it mean when you're going north? It means you're going vertically up. So is there any horizontal motion right or left? No. So that's why your I is 0. But your j is 5. طيب. Now, I was initially moving at this. Now, can I subtract the velocities? Yes. Since you now have it in terms of vectors, you can subtract قد ما بدك. Okay, so m delta v, right? M delta v, يعني final velocity at day, final minus initial, right? Final velocity 0i plus 5j. يلا 0i plus 5j minus the initial velocity. So minus, and you put it into brackets. You have to distribute it into the whole vector. And in this case, it's only minus 10i. So ما فرقت. There's no difference. But you're gonna be working with, you're gonna see examples where it's not just 10i 0j. You're gonna see examples with angles. I'm not sure if he put it in the quiz, but there will definitely be questions that are required for us. Anyway, so يعني m v minus u, right? So this is v minus u is what? Minus 10i plus 0j. يلا, solve this. You're gonna get 0.17 outside. 0i خلاص, let's remove it. وهيدي 0j ما لها طعمة. So you're gonna get 5j minus, so it's gonna become plus 10i. Type. Distribute your 0.17. You're gonna get 0.85 j plus 1.7 I. ماشي. Fix it. We say I before j first, so I'm just gonna put this. So this is your change in momentum. What are they saying? They want the magnitude. طب انت you have a vector. How do you find the magnitude? Square root 1.7 squared plus 0.85 squared to one decimal place. يلا خلينا نحلها. 1.7 square plus 0.85 square. هلا بتعملها square root لهيدي 3.6125 صح؟ هذه بتطلع 1.9. So what is the key takeaway over here? Or Newton per second. The key takeaway over here is that when you have two dimensions, up, down, north, south, east, west, please resolve using vectors. Otherwise your answer will not work. Okay? Other people, they use different methods. I don't know. Maybe it might work with you. But this is the method I've been using, and it works perfectly fine for me. And it makes sense. You just have to be a bit good with vectors. Anyway, the angle between the impulse vector and the horizontal to one decimal place. Okay, how do we find the angle? remember, to find the angle we just do shift tan y over x, right? Type, this is my vector. Yalla, let's do shift. Oh, I don't think this calculator can do that, bro. But I can. Shift tan, okay, y over x. So the y component, which is 0.85, divided by the horizontal component 1.7, you get a day 26.5 to one decimal place. To one decimal place 26.6. I think that's one of the other answers over here, you can see. Okay, if the contact between the cue stick and the ball lasts for 0.01 seconds, فأعطوك delta t is 0.01 seconds. هيدي مش 5 هيدي s. Okay, then the average force acting on the ball will be how much? Okay, so they want the force. We have delta t, and we also have the change in momentum. What do we know about the change in momentum? Isn't that the fancy way of saying impulse, J? Right? So don't we know that delta P is equal to J? Right? We know this, right? And don't we know J is equal to F times delta T? Right? Can't we just substitute all our values in now? Of course we can. Delta P, which is 1.9, is equal to the force that we're trying to find, times the delta T, which they gave it to us as 0.01. طيب, هلا to find F, what do? We do 1.9 divided by 1.9, sorry, divided by 0.01. Just like that, you got what? 190 newtons. Very easy. Nothing too hard. والله it's all يعني بدها شوية تركيز. Not too hard. يعني he's really until now nothing too hard. والله they're all straightforward questions. They're just applications of the formula. But usually the vectors questions they don't really come up. It's usually easy applications. In a match of tennis, a player serves a stationary ball with a force of 420 newtons. So they gave us the force with a speed of 15 meters per second. The collision between the racket lasts for 7 milliseconds. What is the mass? Okay, and this is very, very easy. They gave you force, they gave you delta t, they gave you velocity, they want m. What do we know? mv خي is equal to what? F delta t. Type mass times the velocity at times the velocity 50 is equal to the force at 420 times delta t. Please do not put delta t as 7, please. They said milliseconds, for what you have to multiply it by 10 to the power of -3 or divide by 1000 عادي. Let's do this on our calculator. 420 times 0.007 divided by 50, you're gonna get 0.0588. This is in what? Kilograms, right? هني شو بدهم إياه بالgrams. For what do? I multiply by 1000 if I want to convert from kilograms to grams, and I'm gonna get 58.8 grams to one decimal place. Question 7. A particle of mass 3 kilograms is at rest on a smooth horizontal surface. A horizontal force of magnitude 12 newtons acts on the particle for 2 seconds. What's the final speed? Again, guys, these are direct applications of the formula. I'm not gonna screen capture, it's very easy. M is equal to what? 3 kilograms, right? They gave you that the force is 12. وعطوك delta T is what? 2 seconds. شو بدهم? LV. Very, very easy. Okay, what do we know? M delta V is equal to F delta T. Therefore, 3 delta V is equal to the force 12 times 2. Delta V is equal to 24 divided by 3, 8. Since it's acting from rest, that means because delta V is V minus U. Since acting at rest, U is 0, so it's just V. Okay, so V is equal to 8 meters per second. يمكن maybe Mr. Hani woke up on the wrong side of the bed and he decided instead of starting at rest is moving at what? Is moving at 1 meters per second. What do you have to do? You got delta V is equal to 8. You just subtract by 1. You get 7 meters per second. Let's say that's if it's on a bad day. Okay, but I don't think you'll ever get a question like this. But just you have to be paying attention to these types of things. What is the change in momentum in the interval 0-13? Okay, you need to know that the change in momentum delta P is equal to J, which is equal to F delta T. In other words, it's the area. When you have something is equal to something times something, it's the area under that graph, under the FT graph. Similarly, when you have work is equal to force times distance, I think you guys remember this, it's also the area under the FD graph. So basically انت هلا شفت اللي what is the change in momentum in the interval 0-13 and they gave you a graph. يعني بشرفك please guys, if you see a graph or they tell you what is the change in momentum, يعني what else are you going to do other than calculate the area? You know what I mean? يعني use your head a bit. What else did you ever learn other than calculating the area when seeing a graph? طيب ليك from 0 until 13 we need to calculate the area under the FT graph. طيب you can calculate the square or rectangle and then this triangle over here and then this mini triangle over here, whatever you want. I'll take it as a trapezoid. Okay, base 1. If it's written part, please, you have to write this. Okay, and you have to write this is for area from 0 until 11, and from 11 till 13, since it's a triangle, it's BH over 2. Okay, you need to write these formulas. They deducted before if you don't write them, which is annoying, but yalla. Anyway, from 0 to 11, base 1 is how much? This long base at the bottom, you see it, that's 11. Base 2 is from 0 until 6 over 2 times the height at the height تبعتها 7, so you're gonna get 17 over 2 times 7. Why do they have to give me an odd number? 17 over 2 is 8.5. 8.5 times 7 is 56. 59.5. I think 59.5. بعدين from 11 to 13 it's base times height over 2. البase تبعتها 2, الهايت تبعتها negative 2 over 2 is equal to negative 2. Okay, so now what do? You add up these two areas. Okay, so 59.5 minus 2 is equal to 57.5 Newton second. طيب, please pay attention. Some people here, they get a negative area, they make it positive. Why? علمي علمك, I don't even know. Okay, if it's under the graph, under the x-axis, then it's pretty obvious that it should be a negative answer. So that means you should subtract it instead of adding it. Okay, فبليز يعني إذا بيطلع لك negative 2, don't make it positive and then get added to 59 and get 61.5. No, please don't do this. Anyway, I think this is 22 questions. خلاص, other than this, the rest of the sections are not that hard صراحة. Consider a 0.5 kilogram toy car that is equipped with an automatic rubber bullet rifle. The car initially at rest starts moving when the rifle fires a 0.05 kilogram bullet with a speed of 20 meters per second in the positive direction. What is the velocity of the car after the bullet launches? Okay, let's see. Do they have positive 2 as an answer? No. Type. Let's draw this so you can understand. What do we have given? We have m is equal to 0.5 of the car. It's initially at rest, so we can say it's 0. It starts moving when the rifle fires a 0.05 kilogram bullet. So the mass of the bullet is 0.05 kilogram with a speed of 20 meters per second in the positive direction. U is 20 meters per second in the positive direction. Okay, this is important. Neglecting friction, the velocity of the car after the bullet launches. Type. They want what? The car. Let's draw it. You have your car over here. You have, I don't know, let's say on top of it is like a toy gun, so I don't get demonetized. It's a toy gun over here, and it shoots a bullet, right? So how does this car work? It shoots this here that pushes the car what? To the left, right? This is similar to, I gave it one time as an example, as the fire extinguisher example. When you shoot a fire extinguisher to the right, it pushes you back to the left, right? So this is actually Newton's third law. For every action, there's an equal and opposite reaction. So when you shoot to the right, it's gonna propel the car towards the left. Okay. Anyways, how do we work with something like this? Obviously, they said take the direction of the bullet to be positive, right? So this over here will be negative, but you don't know for sure. Anyways, how do you do this? you need to know the conservation of momentum, and this states P before is equal to P after. Okay, in other words, when you have something where something's being shot to the right, or someone's colliding to the right, or someone's any collision, anything where there is a change in momentum, I used earlier with the first collision, it was what? A change in momentum is m delta v, right? But they're not asking for change in momentum. In general, when you have a collision, or this was question 1, remember when the guy who shot a ball into the wall, that was change in momentum. Here they're not asking change in momentum, they're asking for the actual velocity. Anytime you have a collision or anything, you have to use this. P before is equal to P after. So what does this mean? It means P initial of the car plus P initial of the bullet is equal to P final of the car plus P final of the bullet. And then from here, you cancel out. We know that the car is initially at rest. P is mv, so v is 0, because it's at rest, this gets cancelled. We know at the end that the bullet خلاص, you shot it, it doesn't have velocity anymore. The final momentum of the bullet will also be 0. So that means you're left with this. P initial of the bullet is equal to P final of the car. So what is the initial momentum of the bullet? It's the mass of the bullet, times the initial velocity of the bullet. And the momentum of the car is the mass of the car times the final velocity of the car. Yeah, let's do it. Mass of bullet is 0.05 times the initial velocity of it is 20 meters per second in the positive direction, equals mass of car, which is 0.5 times the velocity of the car that we don't know, we're trying to find it. Okay, anyway, you're gonna get here v car to be 2 meters per second, and you're gonna get a positive answer. Now this, and I paused the recording for 5 minutes. I was like, whoa, why is it positive? Shouldn't it be negative? This is where أنا خبصت. Over here, I took that the final momentum of the bullet is 0, when it's not 0. The bullet, initially, its momentum was 0. Why? It's because the bullet, like, the car was at rest, وكمان the bullet was initially at rest. Nothing happened. They were both initially at rest until when we decided to fire it. That instant is when the car also decided to move. So for that reason, I should have taken that the P initial of the bullet is 0 as well. So 0 is equal to P final of the car plus P final of the bullet. Okay, if that's my mistake, I apologize. Okay, so you're gonna get, let me clean this up. 0 is equal to mass of car times velocity of car plus mass of bullet times velocity of bullet. So 0 is equal to mass of car 0.5 times velocity of car, we don't know it, plus mass of bullet, which is 0.05 times velocity of bullet is 20 in the positive direction. Solve this, you're gonna get now negative 2 meters per second. Okay, very easy, not too hard. And I messed up. So anytime you have a collision, or anytime you have something leading to another movement, you always use the conservation of momentum, which is P before equals P after. Okay, a sphere A mass 3 kg lies at rest. A second sphere, so lies at rest, for its U of A is equal to 0. Okay, by the way, for P before equals P after, in other words, what people do is they say MAUA plus MBUB is equal to MAVA plus MBVB. Instead of using U and V, some people say V and then V prime. That's completely normal, but this is what I like to use. Okay, for the last question, I should have just wrote this for you. I think it would have been way easier if I wrote this for you. Okay, anyways, so here we have a collision. You need to use whatever. You need to use the conservation of energy. So this is, they told us U A is at rest. طيب, a second sphere of mass B, second sphere B of mass 1 kilogram is moving with speed 2, so its U is 2 meters per second, and collides directly with A, and the two spheres combine after impact. What does that mean? VA is equal to VB if they combine. And what type of collision is this, by the way? This is inelastic, right? this is for later. The common speed of spheres A and B is how much? Let's see. Okay, so again, since it's a collision, we're gonna use our famous formula, this one. Okay, any collision, this will work always. طيب, let's start MAUA. Since A is at rest, we're gonna cancel this out. MBUB, so the mass of B is 1, UB is how much? 2. Okay, we're gonna take this to be the positive direction, okay? Equals the mass of A, 3, VA and VB. Since they're equal, I'm just gonna replace them both by B. Okay, mass of B is 1, so we're gonna replace it by B. So you're gonna get 2 is equal to 4V, so V is equal to 0.5 meter per second. Very easy. Collisions, I like this chapter a lot now because it's so direct. There's no thinking at all whatsoever. طيب, a ball P moving at 6 meters per second hits an identical ball Q moving at 4 meters per second in the same direction as P. After impact, both balls move in the same direction along a straight line. After impact, the speed of Q, VQ, is triple VP. So what does that mean? VQ is equal to 3 VP. So we're gonna use this and solve it. Again, it's an impact, it's a collision. For what famous formula are we going to use? We're gonna use MA UA plus MB UB is equal to MA VA plus MB VB. Well, obviously in this case we're not using A and B, we're using P and Q. So let me just P. Let me fix these. Hold up. No. Okay, so MP Q P Q. Type. Let's start substituting. Mass of P is a day P. We don't know. They're identical. Oh, okay. They're identical balls. For mass of P is equal to mass of Q. Type. Okay. What does that mean, guys? If they're identical, معناتها you can cancel M in the whole equation, huh? So UP plus UQ is equal to VP plus VQ. طيب نحن what do we know about VQ? It's equal to 3VP. So let's substitute that. So UP plus UQ is equal to VP plus 3VP. And before substituting, I'm gonna put in the numbers and then substitute because I feel like people hate working with letters and variables. And I'm a student, like I understand all that. So let's substitute numbers first. UP, what's P initially moving at 6 meters per second. UQ is 4 meters per second. The final velocity of P, we don't know VP or VQ. This is where we substitute VQ as 3VP. So VP plus VQ, which is what? 3VP. طيب يلا شو بنطلع؟ 10 is equal to 4VP. فأكيد VP is equal to 2.5 meters per second. نحنا we want both VP and VQ. طيب إذا VP is 2.5, VQ is 3 times 2.5, which is what يا حبيبي? 7.5 meters per second. Very easy. Okay, so VP 2.5, VQ is 7.5. Nice and easy, guys. Question 12. By Newton's second law, this comes out. It always comes. The net force acting on a particle is equal to the rate of change of its momentum. How did this come in the exam? I remember exactly how it came. They said Newton's second law, and they said it means the change of momentum is equal to the net force. These were the answers. And then they said B, it can be expressed as... I remember, okay, I don't know about part A, but I remember seeing for sure Newton's second law can be expressed as... This definitely came in the exam, I saw it. Delta P... the net force is equal to dP over dt. Okay, حطوا لك vectors. Okay, this was the answer. You had to select this. Okay. Let me erase this. Anyways, by Newton's second law, the net force acting on a particle is equal to the rate of change of its momentum. By the way, this is almost the same thing as this was. Remember we said, what's it called? Impulse J. Remember when we said J is equal to delta p. Remember we said impulse is just a fancy way of saying change in momentum. So what is impulse? It's f delta t. So okay, you now have f delta t is equal to delta p, which is what? M delta v, right? So okay, if you divide by time on both sides, what are you gonna get? You're gonna get f is equal to m delta v over delta t. What is m delta v? It's the change in momentum, right? Over delta t. So when we say rate of change, what does that mean? That means divided by time. So this is the same thing. I just proved it for you. Okay, very simple. But like I said, it came in the exam like this. You have to choose this: dp over dt. Question 13. The diagram below shows a force acting on a particle varied with time. What is impulse? Again, guys, impulse f delta t is equal to the area under the ft graph. For here, we just have a triangle with base 0.30. Remember, please write, if it's a written part, write this, okay? Write the formula for the area that you're using. So 0.30 times 40 divided by 2 هيطلع لك 0.6 times, yeah, 6 Newton per second. Very, very simple. Question 14. A stationary rifle. This is the same. This is the famous bullet rifle question we see every time. Every exam this comes. Anyway, a stationary rifle of mass 2.8 kilograms fires a bullet of mass 25 grams with a speed of 115 meters per second. What is the recoil? Anytime you have recoil, gun, bullet firing, recoiling backwards, or collision, what do we use? Yalla, in this case, we're going to use rifle and bullet. So mass rifle, U rifle plus mass bullet, U bullet is equal to mass rifle, V rifle plus mass bullet, V bullet. What do we know? That the rifle is stationary, so we're going to X that out. We also know what do we know? That the bullet is also initially stationary. The rifle only began to move once the bullet began to move. Okay, so initially both the bullet and rifle are stationary. They didn't move until the bullet decided to move. That's when our rifle was like, oh, it's pushing me, let me go back. Okay, but anyway, we're gonna get 0 is equal to mass rifle, which is 2.8, V rifle we don't know, plus mass bullet, which is 0.025 in kilograms, times velocity bullet 150. Anyway, you're gonna solve for this, you take it to the left, you're gonna get V rifle is equal to, you're gonna get 1.3. Let's do it on a calculator. Negative, you should get negative, huh? 150 times 0.025 divided by negative 2.8. You can get negative 1.3. Yeah, so you can get negative 1.3 meters per second, but Akidi said speed, so that's why you take the positive answer. If this was a written part, we solved it like this. Mass bullet, if you did this in your written part, I know people just do this, okay? The rifle, sorry, is equal to 0.025 times 150. People, I am sure people do this, they're gonna get this, they're gonna say خلاص ختمنا الامتحان ويلا. والله here if it was out of 2 marks, honestly, if I were a teacher, I would give you maybe half صراحة. Because Laffy formula مظبوط and you got the wrong answer. You shouldn't even get any mark, it should be 0 mark. Okay, so my recording cut off and I lost the what do you call it? I don't know how to talk. I lost the, what do you call it when you write on the screen? The drawing, the writing, whatever. I lost it. Anyway, what I'm trying to tell you is, why is that wrong? Why is it wrong to do just mass times velocity equals mass times velocity? It's wrong. Obviously, if it's a computer part, please don't waste your time. I do this, huh? If it's computer, do this fast. Don't even think about it. But if it's a written part, you need to do the full formula. You have to. Why? It's because if you do this, you're gonna get a positive answer, and it should definitely not be positive. It should be opposing the direction of the bullet. Because انت عندك الgun هون, a fake gun, huh? So I don't get demonetized, please. You shoot it here, the rifle goes to the left. So how on earth can the recoil speed be the same as the speed of the bullet? No way, it's impossible. For that reason, if this was a written part, this will definitely not be accepted. Okay, you have to do the full formula. Okay. and so on and so forth. I'm going to continue. Question 15. A force of 600 newtons is exerted for, this is very easy. J is impulse, F delta T, صح? For 600 times 0.05, you get 30. Question 16. Did I skip now? Okay. 16. A mass 250 grams moving at 12 meters per second. What is the momentum? Again, I'm not even gonna write. P is equal to mv, right? So 0.25 times 12, 3 kilogram meters per second. Please pay attention to the units, huh, guys? A tennis ball of mass 60 gram moving at 25 meters per second collides with a wall and bounces back with the same speed. What is the net impulse imparted by the wall? Yalla. What are they asking for? Impulse. Do we have force? Do we have delta T? No. So what do we say when there's no force, no delta T? How do we calculate impulse? We said it's just a fancy way of saying change in momentum, which is what? M delta V. طيب يلا. What is the mass? 0.06 times. What is the final velocity? Please don't do this because you're gonna get 0. And I don't think it's possible for you to get 0. You're colliding. أكيد it would be wrong for you to get 0. Why is that? What do you do? Someone's going to do, okay, what do I do? طب يلا عندك البال. It's going here. U is 25 meters per second. It collides and goes back at V. It's 25 meters per second. What do I tell you? In every collision, every recoil, every momentum problem, what do you need to take? You need to take a positive direction, يا حبيبي. For taking the right to be the positive direction, that means the V, the final velocity, will be negative. Okay, so when doing M delta V, you're gonna get 0.06 times the final velocity, negative 25, minus the initial velocity, 25, and you're gonna get, this is negative 50, times 0.06, you're gonna get negative 3 Newton per second. But let me see if positive, if negative 3 is an answer. It should be, صراحة. It's not. Okay, for some reason negative 3 isn't accepted, which is completely confusing because it should definitely be accepted. They didn't say take anything to be the positive, and they didn't say magnitude, so negative 3 should well be accepted. If someone has any idea as to why it is not accepted and it should be positive, please place it in the comments and I will definitely consider your comment. I don't understand why negative is wrong. Question 18. The force acting on a particle is given by between, what is this? Okay, for the first, okay, so you can try and let me screenshot this. Why does he give it like this? Okay, so F is equal to 2 newtons or 2 newtons per second T. So ignore this unit, always what's inside the bracket, ignore it. So 2T and then 1 minus 0.5 T. Okay, so you're gonna tell me, how is he giving me two forces? He gave you from 0 to 0.4 seconds, the force is 2T, and then from 0.4 seconds until 2 seconds, it's 1 minus 0.5 T. How will the speed of the particle be affected by the force F acting on it? I think it's pretty self-explanatory that it's obviously gonna speed up, right? If you don't believe me, by the way, substitute values like مثلا 2T 0.4, right? 2 times 0.4, that's 0.8 newtons. Try 0.4 over here, you're also gonna get 0.8. Then مثلا try 1 second, you're gonna get a bigger value such as 1 minus 0.5 times 1, 0.5. Okay, yeah, it's just gonna speed up. I think if there's a force, there's acceleration. It's gonna speed up. Obviously, if there's a force, it's gonna accelerate, so it's gonna speed up. Which of the following best explains your answer? To A, the impulse by this force is positive. Okay, chat. This took me a few seconds to get, but now I understand what's going on. Okay. If you see this question, I'm 100% sure you won't see it, but this is more of an understanding. If you remember, we said F is equal to dP over dt. So when they write force in terms of T, how do you think I can get the momentum? مش أنا if I integrate both sides I can cancel the derivative. مش integrating is the opposite of the derivative. So basically you're gonna get that momentum is actually the integral of f with respect to time. Okay, so on 2t, right? You have f is equal to 2t. Integral of 2t is what? With dt, with respect to time, is t squared plus c. And then integral of 1 minus t is what? T minus 2 t squared over 2 plus c. So they're talking initially. So initially it's stationary. What will happen to the speed? For the first 0.4 seconds, what's happening to the speed? For the first 0.4 seconds, it's initially stationary. It was applied by a momentum of t squared. T squared, is it a positive momentum or a negative momentum? Of course, it's going to be positive. Why is it positive? Because it's square. It's square. Don't tell me plus c. Insert plus c هلا. T squared, right? It's a positive momentum. If you want to think about it from 0 to 0.4, insert plus c. Okay? So since it's square, it will always be positive. For that reason, it's going to speed up. ماشي. What is the impulse imparted on the particle by the impulsive force to the nearest decimal place? نحن, do we have F delta T? We don't have any force, we don't have any time, right? But we can calculate impulse by doing what? J is equal to the change in momentum. Okay, what is our initial momentum? Isn't it this integral from 0 to 0.4 of 2t dt, which we figured it out to be t squared, but isn't it's just t squared from 0 to 0.4. Then P final, it's integral from 0.4 until 2 of what? 1 minus t, which we found dt, which we found to be t minus t squared over 2 from what? 0.4 until 2. طب يلا, let's calculate. Final will be 2 minus 4 over 2, because 4 is 2 squared, minus 0.4 minus 0.4 squared over 2. Let me try doing this. Okay, calculator. Okay, 2 minus 2 minus 0.4, لا same. هيدي 0. اوكي خلاص. 0.4 minus يا الله 0.4 squared squared divided by 2. Okay, 0.30. So this is the final. طيب والinitial قد ايه الinitial? t squared. Okay, so ما عنده بدون magnitude هون. Okay, minus 0.4 squared. Oh, I got 0.8. Am I forgetting something? Let me take a look and see. Okay, yeah. I'm blind. I didn't see that they want the impulse by the impulsive force, only the impulsive force, and the impulsive force was the one that we were talking about here, the one initially, the t squared that sped up our particle. فكله هيدا على الفاضي. The only thing we care about here is just this over here. Okay, this, I don't care about the second part. Okay, I'm 100% sure you're probably not ever gonna see a question like this, but خلاص, P is integral F. Okay, anyway, so this from 0.4 to 0, you're gonna get 0.4 squared, but still that doesn't get you 0.8. What is this? Yeah, so you're gonna get 0.16. Like I've been like look, I screenshot this at 11:08. It's 11:22. I'm telling you the quiz is wrong. It should be 0.16. I've been trying to figure this out for 10 minutes, 14 minutes actually. I even used the eyeball. خلاص, this question, skip it, man. Don't bother doing it. It's not gonna come. Definitely won't come. Okay, question 19. No, what are these questions, bro? This stuff never comes. 3-point objects P, Q, and R of masses 5, 3, and 2 are placed as shown in the diagram below. The x coordinate of the center of mass to one decimal place and the y coordinate of the center of mass. Okay, how do we find the center of mass? X center of mass, I'm gonna screen right. No, why would this one select? Screen right. Type. The formula for the center of mass is m1 x1 plus m2 x2 and so on and so forth over m1 plus m2 and so on and so forth for as many masses as you want. The actual formula, in case you do see it, is sigma from n is equal to 1 up until infinity, or no, sorry, from I is equal to 1 up until n of mi xi over sigma sigma from I is equal to 1 until n of mi. Okay, basically it means add up all the mass times their x coordinates over all the masses. Okay, in case you see it, this is the formula, it was in the book. And the same goes for y, of course. Y is equal to sigma mi yi from I is equal to 1 up until n. Basically up until n basically means if you have n objects up until n, and you keep on adding until n. Let's say you have 5 masses, you go m1 y1, m2 y2, m3 y2, m3 y3, m4 y4, m5 y5. That's where you end. Over sigma I from I is equal to 1 up until n. Okay, this is if it was y. Anyways, very easy. Let's not waste too much time. So over here we have point R, P, and Q. R is over here at -2, 1. P is at 1, 3, and Q is at 4, -1. Type. Let's start. For our center of mass, x center of mass, let's start with mass of R times the x coordinate of R. The mass of, let's start with P since P is given first. The mass of P is 5 times, because remember it's mx plus mx plus mx over m plus m plus m, right? So 5 times the x coordinate of P, which is 1, plus, let's use Q, the mass of Q times the x coordinate of Q, which is 4. R, the mass of R, which is 2, plus the x coordinate of R is -2, over mass plus mass plus mass, right? So 5 plus 3 plus 2. Let's do this on our calculator. Actually, you can do this in your head. 5 plus 12 is 17, plus 17 minus 4 is 2, 13. 13 over 8 plus 2 is 10, so 13 divided by 10, which is 1.3. So the x of the center of mass is 1.3. By the way, this dash means center of mass, no? 1.3 meters. So that is part A. For the y of center of mass, we're gonna do m1 y1 plus m2 y2 plus m3 y3. Yeah. Again, let's use the same masses. 5. So we start with P. The y coordinate of P is 3, plus the second mass we're gonna use Q. 3 times the y coordinate of Q is -1, plus the third mass is R. So the mass of R is 2 times the y coordinate of R is how much? 1. Type. Perfect. Over mass plus mass plus mass, so 5 plus 3 plus 2, yalla, 15, minus 3, 12, 12 plus 2, 14, 14 divided by 8 plus 2, 10, you're gonna get 1.4 meters, so this is correct. Type. Okay, this is kind of blocking the way, I can't really see type. I think I'm gonna have to close and open this again. Okay, particle R now moves at a constant speed of 1 meter per second horizontally away from the origin, while P and Q remain at rest. The speed of the center of mass to one decimal place is how much? This is the exact same formula. Similarly to how we have x center of mass is equal to sigma mi xi from I equals 1 until n over sigma m. Same exact thing, but now with what? We're talking about what? Speeds. Okay, so the speed of the center of mass follows the exact same formula, but instead of x, I'm gonna use what? V. For mi vi from v is equal to, from I is equal to 1 up until n over sigma mi from I is equal to 1 until n. فsame thing. بس شو قالوا لنا P and Q are at rest, VP is 0 و VQ is قد ايه 0, بس قالوا لنا قد ايه VR is what 1. Let's solve this. So mass times velocity times plus mass times velocity plus mass times velocity over mass plus mass plus mass, same exactly. Yalla, so V center of mass will be how much? Let's start with P. So 5 times velocity of P, which is 0, plus Q 3 times a day 0, plus R. They told us it's 1. The mass of R is 2, so 2 times its velocity 1 over mass plus mass plus mass. Even if their velocities are 0, you must still include their masses. My S Pen is tweaking. yeah, you must still include their masses. So 5 plus 3 plus 2. So you're gonna get 2 over 8 plus 2, 10, which is what? 0.2 meter per second. Very nice. Okay, question 20. An object of mass 400 gram is projected at a speed of 25 meters per second at an angle of 30 degrees with the horizontal. The initial linear momentum of the projectile is how much? I think no عادي. I don't think that the 30 degrees has to do with anything. So let me just make sure. 0.4 times 25 0.4 times 25. Yeah, خلاص عادي. The 30 degrees doesn't matter. I don't know why they put 30. طيب okay, just so you can kind of see what's going on, they're basically saying it's like 30 degrees like this. Okay, this is the momentum. طب هلا شو فرقت? It still has the mass which is 400 grams, which still has the velocity which is 25 meters per second. طب نحنا ال P it's equal to mass times velocity, so 0.4 times 25. ما جبنا سيرة الانجل. It can be here خي, it can be هيك 45 degrees downwards. ما فرقت, بس the momentum is still momentum. Okay, you just multiply. Do what you learned, what you were taught. No one ever taught you anything about angles to do with momentum, okay, unless you're doing collisions, right? Okay, that's a different story. 21. A cart of mass 8 kilograms is moving at 1.5 meter per second. في collision بالموضوع. Another car of mass 2 kilograms, and after collision the carts move together. So what does that mean? Let's call cart A and cart B. So VA is equal to VB since they move together, right? And what collision is this? This is an inelastic collision. طيب ماشي, يلا let's do what do we do when we have collisions? MA UA plus MB UB is equal to MA VA plus MB VB. يلا cart A خلينا نقول mass تبعتها 8, it's moving at 1.5, plus cart B قلنا it's initially at rest فهيدي 0. okay, is equal to MAVA. الماss تبع A is 8, with final velocity VA is equal to VB, so we're just going to replace it with a V. Okay, let's just say VA. If this was a written part أحسن اكتب VA, or no, you can say إنه مثلا you have to write this on the side. You have to say VA equals VB equals V. Okay, and then continue solving, or you want to keep it all in terms of VA or keep it all in terms of VB عادي. Okay, but just make sure you write this on the side if it was written. Okay, anyway, plus a mass of B a day 2 times V. يلا كملوا. 8 times 1.5 will be say 12 is equal to 8V plus 2V, ف 10V is equal to 12, V is equal to 1.2 meter per second. حلو, very easy, and these questions no difficulty until now. This whole quiz كله no difficulty, بس يعني the questions are long, they're just long. Some of them are a bit tricky. A tennis ball of mass 100 grams moving at 5 meters per second في collision بالموضوع collides with a wall that exerts a force of 240 newtons. What is the duration of the collision? يلا توقعتها. Okay, so they gave you the mass, and before don't even draw يا أخي. When you have mass you have the velocity عندك الفورس وبدون سبحان الله duration بدون الدلتا t. How do we solve this? What do we know? J is equal to delta P is equal to F delta T is equal to M delta V. This is what we care about, right? So 240 times the delta T, which we need to find, is equal to the mass 0.1 kilograms, okay, times the delta V 5 meters per second. No, خلاص MV. ماشي, so you're gonna get 240 delta T. خلاص I have to remove it a lot. Anyway, we said F delta T is equal to MV, ف 240 delta T is equal to the mass 0.1 times V, which is 5. ماشي, يلا delta T is equal to هيدي 0.5 على 240. let's see 200. يا عمي افتح خلاص افتح. ماشي, 240 as the 0.5 divided by 240 بيطلع لك Hold up. Did I do something wrong? What is the duration? Yeah. It was mv, mass 0.1, velocity 5. Yeah, I'm saying okay. The formula was okay. J is equal to F delta T, which is equal to the change in momentum, which is equal to M delta V. And I'm solving as if it started at rest. But here it started at 5 meters per second. It collides and rebounds with the same speed. ففي initial velocity وفي final velocity. Okay? For that reason, please don't make the same mistake I did. ما في formula MV، ما في F delta T MV، لا. It has to be delta V. عادة يا الله يا عمي. Oh my god, this tablet. F delta T is equal to M delta V. What is delta V? Yalla. And I was telling you it's an easy exercise. Look at me now. Yalla. So you hit it with 5 meters per second. Hey, it's your U value. So then it rebounds back at V is equal to 5 meters per second. So always then when you have a collision and you have this hits a wall or madri shu, you have to take a positive direction. So let's take the initial to be positive, and that means the rebounded direction will be negative. What does this mean? U will be positive, or V will be negative 5 meters per second. ماشي, very easy. هلا we can solve very easily. The mass is 0.1 times delta V, which is final minus initial, so minus 5 minus the 5, right? So you're gonna get delta T is equal to 0.1 times negative 10 over 240. فهيدي it's very easy. هيدي 0.1 hold up 0.1 times negative 10 divided by 240. You're gonna get obviously a negative answer, but we know that time is definitely not negative, it has to be positive. So you're gonna get 0.0000, okay, but they want it in milliseconds. For what do we do when we want it in milliseconds? We multiply it by 1000, right? So you're gonna get ignore the negative, you're gonna get 4.2 milliseconds. Very, very easy, very, very straightforward. Thank you so much for watching, and good luck in your, if you're watching this, it should be final exam. Good luck.